So now I'm going to discuss about the chapter 4 summary. Chapter 4 is all about the network access. So in sending devices, it is the role of the data link layer to prepare data for transmission and control how the data access the physical media. So the physical layer controls how the data is transmitted onto the physical media and encoding the binary digit that represent data into signals. So type of connection, a physical connection can be a wired connection using cable or a wireless connection using radio waves. So data, what is data? Data is transmitted through a physical cable. So to offer wireless capability, devices on a wireless network must be connected to a wireless access point or AP. Switch devices and wireless access point are often two separate dedicated devices within a network implementation. So, in many homes, for example, individuals are implementing home integrated service router. So, network interface card. So, what is network interface card? Network interface card connect devices to the network. Ethernet and IC are used for wide connection as where are used for the wireless. Um, all wireless devices must share access to the airwaves connecting to the wireless access point. Then I have a trivia. The further the device is from the access point, the weaker the wireless signal is received. So, example of this is when I was connecting on the Wi-Fi of the school, where if when I was in the first floor and the second floor and maybe on the third floor, the connection is fast and in the first click it is load the data that want to get load faster. But if it is if I was in the fourth floor or even in the fifth floor, the Wi-Fi signals is getting weaker and weaker, and it takes too long time to upload or download or even load a files on the internet. Then it can lose patience first because you are further on the source of the internet or the access point. That's why it become weaker. So the physical layer media. The physical layer produces the representation of groupings of bits for each type of media. The copper cable, fiber optic cable, and the wireless cable. Copper cable, the signals are pattern of electrical pulses. So when you say in copper cable, signals that are passing through this cable are electrical pulses because copper is a good conductor of electricity. Then the fiber optic cable. In the fiber optic cable, the signals are pattern of light. So in a fiber optic from broad optic, which is light, passes through that. Then the wireless. Provided it's a wireless, it is not doesn't need wire. The signals and pattern of microwave transmission. So through the microwaves, it happens. It's possible for the wireless transmission. So the physical layer standard addresses three function areas: the physical component, encoding, and signaling. So the physical component are electronic hardware devices, media, and another connectors that transmit and carry the signals to represent bits. Hardware components such as NIC or network interface card and connectors, cable materials, and cable designer are all specified in standard associated with the physical layer. Next is encoding. Encoding, what is encoding? From my first impression, my first um knowledge about encoding is just um typing from the computer to the computer from the use of a keyboard. So what is coding? Encoding or line encoding is a method of converting a stream of data bits into predefined codes. Encoding from words of code. So it uses code. What is code? Codes are groupings of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. So next is the signaling. What is the signaling? The physical layer must generate the electrical or optical or wireless signal that represent ones and zeros on the media. The, so signalings, the method of representing the bits. That is what we call signaling. Bits are the ones and the zeros, which is understandable by the computer. So this similar to the signaling method used in Morse code. Do you know what is Morse code? Morse code is commonly used for, I think, for the military. And as I see for the Morse code, it is dot and dash line, the long dash line or short dash line, which represent a character. So it is like an pulses or pulses. There are many ways to transmit signals. A common method to send data is using modulation technique. So what is modulation? Modulation is the process of which the characteristic of a one wave, the signal, modifies another wave, the carrier. So next is bandwidth. What is bandwidth? Bandwidth, um, data transfer is usually discussed in terms of bandwidth and throughput. So bandwidth is the capability or capacity of the medium to carry a data. So there are different medium. So the bandwidth refers for the capacity of those different medium. And the throughput is the measure of transfer of bits across the media over a given period of time. That is about throughput. Then what is latency? What is latency all about? Latency refers to the amount of time to include delay for data to travel from a given point or another. That is about the delay, the latency. Then there are different characteristics in copper cabling. And of course, there are also an interfaces or blocks on the signals on the copper. So there are two types, or two of them are the electromagnetic interference or EMI, and or the radio frequency interference or RFI. EMI and RFI signals can distort and corrupt the data signals being carried by a copper media. So the EMI and RFI, what happened to the data that is transmitted is being corrupt. Electromagnetic interference is disturbances through the electromagnetic, and radio frequency interferences to the radio frequency. Or the, and last is the crosstalk. What is crosstalk? It is a disturbance caused by electric or magnetic field of a signal on the wire to a signal in a adjacent wire. So there are three main types of copper media used in networking: the unshielded twisted pair, shielded twisted pair, and the coaxial. Excuse me. So what are the difference between those three? Unshielded twisted pair, of course, is most common networking media. UTP cabling, terminated with the RJ45 connectors. It is cable consisting of four color-coded wires twisted together. The twisting of wire helps protect against signal interference from other wires. So shield twisted pair cable is provides better noise protection than the UTP cabling. However, compared to UTP cabling, STP cable is more expensive and difficult to install. Next, and the third one is the coaxial cable. Coaxial, or coax for short, gets its name from the fact that there are two conductors that share the same axis as shown. Our cable consists of a copper cable conductor used to transmit the electromagnetic signals and a layer of flexible plastic insulation surrounded a copper conductor. Next is the UTP connectors. UTP cable is usually terminated with an RJ45 connector. This connector is used to range a physical layer specification, of which is Ethernet. So, as you can see on this drawing, if you can see it, yes, in this drawing, so the T568A and the T568B. What is the difference between two? The position of the color of the wire, orange and green. So in TCP and in T568A, the green color or the green stripe color is on the pin 1 and the green not stripe color, the pure green is in the pin 2. And the orange and the another orange in the middle of it is the pair 1, which is the blue color. Compared to the T568B, orange is on the pin 1 and pin 2, while in the side of the blue cable there are green they're the green color pair. So types of UTP cable. There are different types of UTP cable. Types that are obtained by the specific wiring convention. The Ethernet straight through, the Ethernet crossover, and the rollover. Ethernet straight to the most common type of networking cable. It is common used to interconnect or a host to switch and switch the router. Ethernet crossover, a cable used to interconnect similar devices. And the rollover is a Cisco proprietary cable used to connect a workstation to a router or switch console port. So that's all for the summary for the chapter 4.